There's very few times in my life where I've sold something and then really come to regret it. In fact, I can only really think of a couple of times that that's happened. Back in the day, I had an Acorn A3010 with a hard disk in there, and I did a lot of programming on that. And I really did miss that little Acorn very much. I moved on to PCs and Linux systems and what have you. So I left my little Acorn behind, and I really think I probably gave it away. In particular, I really miss these green keys. You can see I've made myself a normal daily driver keyboard. This is the one that I use for work, because this is the office that I work in as well. And I've put some red keys on there. I would like to get some green keys for that. This one was online with no information about it whatsoever. I won this on Monday night, and it is now Thursday, and this has arrived. On the top here, we've got South Harford Middle School, maybe. So this has been used in a school, which is unusual because they would normally have A3020s, which have Ethernet and hard disk capabilities, or A3000s and what have you. The A3010 was mainly aimed at home use. The power supply cord has been snipped. Moving around to the back, this was basically a home machine, and because of that, the expansion is a little bit more limited than you would find on the A3000 and the 3020s. And there's an expansion port cover here, and they never fit very well for some reason. You always get this problem where they're kind of bulging out like that. That is fairly normal because it was designed for home market in 1992. This is a UHF output, so that goes onto your telly, and RF output. We have a monitor output. Now this will drive RGB monitors, like the old Cub monitors or analog versions of the Cub monitors, but also will drive VGA as well. Probably the best picture that we'll get is a 640 by 480 output in VGA mode. We've got a headphone output, we've got the mouse output. Now that mouse output, that looks like PS2, but it is not a PS2 mouse port. It has got 9 pins, I think, and it's a quadrature mouse, which means that you've got 2 pins for the X and the Y, and then 1 for each of the 3 buttons. And on the Acorn, you really do need that 3-button mouse. Then we have an RS-232 over here, and then 2 joystick ports, because it's obviously designed for home use. And then a printer port. I had a Canon BJ10 SX printer. It was a tiny little printer. I miss that almost as much as the computer itself. The unit that I had a Watford Electronics IDE interface that sat inside here, and it had a Tidbit 30 megabyte hard drive inside it. And obviously it was far better than swapping the discs all of the time. I imagine the disk drive in this probably doesn't work right now, but in most cases they can be made to work. What will have happened is that the grease will have just basically hardened off. So at the moment I don't really know anything about this machine. I've had a quick look around it underneath it for any distinguishing marks. It doesn't look like it's been opened, at least recently. What I have done is there are 3 screws to remove the case. So it's the left one, there's one in the middle and one on the right hand side. What we tend to find is that just like old PCs and what have you, there's a memory backup battery that tends to leak like chloride crystals out and eat away the motherboard. So that's probably going to be the main issue with that. Upon removing the top, I can see that this is one of the later machines with an actual ARM 250. The earlier ones had a board in here because the ARM 250s weren't ready at the time. I think they're the same speed, but they're just made up of of 4 chips instead of a single ARM chip. I've disconnected the keyboard ribbons, and that's because these are quite fragile and I didn't want to damage them. Looking down in the depths of the machine, I can't see any of the green schmoo that I'm expecting to see in here, which is as a result of the leakage from the battery, but I can see that the battery is still in there, so nobody has opened this and removed that particular battery. Now, one of the things that I am noticing about this machine is just how dirty it is on the inside, particularly on the left-hand side here. I mean, it's better on this side, but there is definitely a lot of dirt on this side. And if you look here, you can actually see that it looks to me like there is a tide mark here it looks like this may have been underwater on this left hand side, which is where the power supply is, which is not necessarily a good thing. So we'll need to look very carefully around there. Now that I've disconnected the keyboard ribbon, I'm able to release the actual keyboard and remove it carefully from the machine, and you can see it is absolutely filthy, so that will need to be cleaned. All of the keys seem to move, nothing's stuck, and all of the keys are here as well. It's quite worrying that this side has been, it looks like it's probably been underwater. Well, I'm assuming that this has got, so there's 1 megabyte of RAM on the board, that's what the machine comes with, and then there are 2 memory chips in here. So this, I think, has been upgraded to 2 megabytes. The maximum you could upgrade this machine to in the day was a 4 megabyte machine, but that would have a PCB on here. We can see a little bit more inside, but there's not that much to see at the moment. The RF modulator here is absolutely massively corroded. I'm not quite sure if that's because that's been sat in water or has got damp. But if I look at the surface mount components here on the actual motherboard itself, they don't look too bad at all. I mean, that will clean up absolutely fine. And the legs that you find on some of these things often have corrosion on them, but they're all looking okay at the moment. I will need to look at this very, very carefully, but it's not looking too bad at the moment. So the next thing to do is you remove these 3 screws, one here, one in the middle somewhere here, and then one at the far end over here, and then this assembly moves backwards, and the floppy drive will come with it, and then we'll be able to see what it is that we are dealing with. You can see there's more corrosion on the left hand side here where I think it's probably been wet, and we'll just have to see how that goes. If the worst comes to the worst and we think that the power supply has had it, well, the machine requires plus and minus 12 volts, 5 volts. I don't think it has a 3.3 out of the power supply, so we might be able to arrange that with some kind of mini ITX arrangement that just fits inside here, and then we can just put like a 12 volt adapter. Okay, I have freed everything off and I am able to get a look inside. Let me just put this down here. And there we go. So over here we've got the Riscos ROMs. Over here we've got the I/O device. The very first thing that we've got to worry about in this particular machine is the fact that the battery is still here. And to be honest with you, normally these things just look like a green Christmas tree, but it's not looking too bad at all. It doesn't look like it's leaked that badly. Does it? Does it? How bad does it look? Okay, there is leakage there. I've seen it where it's eaten away like all these capacitors. If we look very carefully, we can actually see there is a fair bit of corrosion just down here on this resistor here, and there's another resistor back over here, and we need to remove this as soon as possible to prevent it from doing any more damage to the main board. Once that's done, we can then replace it with just normal AA batteries, or one of those coin cells will be absolutely fine. I think we might need to stop it charging, so it might need a diode in there if we're going to use a coin cell, but all of that's relatively straightforward. The board itself on this side is not looking too bad. It actually doesn't really even need a clean on this particular side, so that looks okay. The other side though, it's yeah, it's a bit dirtier. It's not terrible. I've seen things that are worse. I've seen things that have been underwater, and for a short period of time, that's not necessarily an issue. I've seen people wash these motherboards in soapy water and to clean it out like that, and I think that's absolutely fine. As long as it's dried out completely before you use it, you would not have any problems with it. But it's also worth making sure that you put deoxit on any of these connectors. It helps you put the ribbons back in, and also make sure that you get a good connection. Same with these, and same with the RAM, especially if we're going to have any problems with that. I'm not worried about the TV modulator being corroded because we'll just convert it to composite. That would be the best way to go. If possible, the best thing to use is going to be the VGA, and of course you can convert VGA to HDMI and all that good stuff. Where water can be a problem will be inside the power supply or a wound component like this, because it can cause short windings. But there is one thing that we could do, and that is that we have links to be able to disconnect the power supply from the rest of the computer itself. Now I'm hoping that this was never powered up once it was wet inside, because that might be game over. But I think what we'll do here is we will isolate the transformer and the power supply from the computer itself, power it up, and then they conveniently tell you where you can measure stuff. So this is your -12, your 0, your 5, and then there's a +12 down here. And then if those are anything like those values, then we should be able to connect it up to the rest of the computer. If you can't remove the links, then I might cut them and then solder them back again, which sounds drastic, but I would rather power up the power supply and check that that works before causing any damage to the rest of the board, because I'm confident that, provided that it's not corroded really badly underneath here, that some people say, oh, you'll need to recap it and all the rest of it. I'm a big fan of leaving the caps where they are unless they are causing a problem. I thought that this was going to be a switch mode power supply, but it looks like a linear power supply to me. Well, it could be on the bottom, but I don't see, these are not 400 volt capacitors, are they? What's that one at the back? I don't know, I can't quite see it from here. What's that one rated at? Could always look at the schematic, couldn't I? Because it's literally in front of me up here. So, yeah, I will look at the schematic. In fact, well, we'll see. Obviously, we've got our arm. It says GPS on it. No idea why, but that's basically a system on a chip. It's almost everything that you need. That really is a central processing unit. This is to do with the audio side of it. Then we've got various logic chips down here, and these basically buffer the inputs, outputs, serial, and what have you. But most of the I/O is done by this chip over here. So looking at this in a little bit more detail, I've managed to liberate it. This has never been obviously removed. I've had a quick look under the board. There's not a lot you can see. But in order to liberate it from the back panel here, then a little bit more complicated surgery is required. And that is because on the back here, we've got these various things holding on to the back panel. So obviously that can stay where it is. But these will have to be removed all the way down here, and then I can't see any screws or anything else that's holding this in, so I think this should come out. We also get to be able to look underneath the power supply, and it's not looking too bad in there, but we'll definitely have to get it out to know more. So now that this has been removed, I can get a closer look at what we're dealing with here. And if we look underneath this board, well, firstly, over at the right hand side here, where the corrosion can be problematic around the battery, I think we're quite lucky here. This is looking absolutely fine over here. And then over the other side, where the power supply is, I was worried that there might be some water that's been trapped under here and some terrible corrosion or something like that, but it is looking absolutely fine. So I'm confident that I can get that power supply working just fine. I'll remove this. You might want to reflow some of these things, and you can see there's definitely evidence of, well, I don't know, it's like pond water that's been in the bottom of there. Looking more closely in the bottom of the actual case, there's quite a lot more corrosion in here, but actually, yeah, for a 30-year-old machine, it's not that bad. To change the actual mains cable, that's going to be really quite straightforward. I can just crimp another one of these together, and I've already got some white mains cable that's exactly the same as this, and I think I will try and use the original mains power supply. Looking down at various traces, particularly around where the power supply is and what have you, it doesn't look like there's really that much to worry about. This is the reset switch, I think, over here. Again, over here, I can see a bit more clearly now what we're dealing with around this battery, and I don't know how well this thing focuses, but there is a resistor here that, what's that called? Resistor 600 or something. That has that's been sort of eaten away, and I don't know whether or not this trace has been eaten away. So what I'll do is I'll just treat that with a bit of IPA, and that should be okay. And there doesn't look to be any damage to the surrounding. The RAM looks like the most recent chips that are in here. the main chip here, of course, that says 9347, so that's going to be week 47 of 1993. That'll be about when I had it. Like I said, I've got the schematic right in front of me. It's literally here on the screen. So what have we got over here? Well, it is actually linear, but also not linear at the same time. Live and neutral comes in, goes through a switch. Then we've got some filtering over here. Then we've got our primary here. There's a little fuse inside the transformer. And then we have two secondaries, one of which is got a center tap in here. And then this goes through a bridge rectifier. So we end up with our sort of DC output voltage here, and I've no idea what that voltage should be. I imagine it's going to be in the range of about 20 volts or something in that region. Probably, yeah, a bit less. Then up here we've got a regulated 12 volts that comes straight off there, so the 12 volts is not switched at all, that's entirely linear. And then down here we've also got, this gives you your unregulated 12 volts. We do have a switch mode power supply here, so this will be generating the 5 volt rail, probably a good couple of amps. That would require quite a large transformer on the primary over here. So what they've done is they have chosen to have a higher voltage output here and then use this chopping thing down here. So this great big inductor over here is this inductor over here. So it's perfectly possible on this for us to get the plus and minus 12 volt. For now, the only thing really of note here is that it's perfectly possible that we'll get these 12 volt rails working positive and minus 12 and this one over here, and we might find that the 5 volt doesn't exist because there's some kind of fault in here. But this is all readily available, and the biggest risk that we've got is going to be this transformer here, because that's going to be problematic. But if that doesn't work, then we could just use a mini ITX to give ourselves the 5 volts plus and minus 12 and the 12 volt regulator. We might find we don't even need the minus 12 volts if we're not going to use the RS-232. Down here, looking at the keyboard controller, this is another thing that we might really struggle with here, because one, the membrane might not work, and the second thing is we might have some kind of electrical problem. There's a fuse over here, and there's a couple of fuses on the actual output rails as well. These will almost certainly be fine, and then we'll need to look at this input fuse. There's no class Y capacitors or anything on here for filtering. They're on the circuit diagram. You can see them clearly there, but they are not fitted for whatever reason. They've not been removed either. So we've got this input fuse over here, so I'll just check that, which sounds okay. There's some more output fuses here, that's good. That one's alright. There's one up here, one over here, and all that looks fine. So here's your transformer, so here's your primary windings here, and there's two lots of secondary windings. So this is the center tapped plus and minus 12 unregulated, and this output here is for the other one. So if we have a look on the primary side, we are seeing about 90 ohms, which is sensible. That means it's unlikely to explode when we plug it into the mains. On the main secondary, we're seeing about an ohm, which is probably okay. That's probably quite a heavy current winding as well. On the other one, what are we looking at there? We are seeing 20 ohms, and then on the, so we're seeing two lots of about 15, and then that gives us a total of 27, well, 30 ohms. So that looks sensible as well. We won't get actually might not get a sensible reading on this second one here, because we are going through the bridge rectifiers here. So far things look good. Probably now remove the battery from over here. You could try desoldering it, but because of the thick metal and the high thermal mass, it's probably just as easy to snip that off. So this is the positive side, that's the negative side. I think what we'll probably do is just snip that off. So what I'm going to need to do is find my snippers, and we can remove that straight from the board right now. So I'll move that over here. And we can see these chloride crystals and what have you knocking around, and obviously it's not designed to be around 30 years. And now we can get a closer look at the actual board itself and see what we're looking at there. So it's not looking too bad. This resistor here is looking a little bit on the crusty side, but I'll have a look on the circuit diagram for that. Usually it's an alkaline that, or chloride crystals that get on here, so in order to stop it you're going to need an acid, so you could use vinegar or what have you. I think most people just use alcohol, and it just waters it down and stops the corrosion. But because of the chemistry behind it, what will tend to happen is that corrosion will run down the wires, go through all the vias and cause all sorts of problems. But I think this board's okay in that regard. It's not good enough just to leave it as it is like that. That will continue to grow until the whole board is probably ruined. The next thing that I have done is I have snipped off the old part of the cable, and what I've done is I've made myself a nice new mains cable, and I've made sure that this is a 3 amp fuse that I've fitted in here and not a 13 amp fuse, because that's what plugs in the UK come with. 13 amps is a very, very large fault current to be having, and that's not really what we want. So we've got a 3 amp fuse in there, and then at the other end I've crimped on exactly the same as it was before, and you can see the corrosion at the back here. It's definitely been sat in water, and I think judging by some of the tide marks, if you just get the lighting right, you can see where the tide marks been, that this was actually set at this kind of angle with the back down, with where the switch is being the deepest part in the water. We need to test this power supply, and now that I've checked that we've got sensible windings, the next thing to do is to power this up. But in case we don't get a very good regulated output, or there's something wrong with the switch mode here, the best thing to do is to isolate the power supply part from the rest of the computer. And there are 2 links to do that. The main 5 volt output is here, which is the link 1, and the 12 volt output is this one up here that's labelled link 2. So those links need to be removed. Obviously link 1 can't be removed, so we'll just snip it and move the parts away from each other. Right, now what I've done now is I have rigged up the earth, and I've put my plug in here, and I've also made sure that the actual switch is on, because you don't want to be trying to flick that switch when this is live, because there's no isolation around here and that fuse is live. So I've really run out of excuses now. Turn it on and see if we hear anything go fizz or pop or anything like that. We treat it as it's live all the time, so we're using these 2 insulated probes and making sure that we're not doing anything else. So let's see what happens. So I'm going to stand out of the way just in case one of these capacitors lets go. 3, 2, 1. Good, nothing has happened. So let's have a look at what's happening. I think this is earth, and we'll try this plus 12 first. So we are getting 13 volts. That's close enough because it's unregulated, and there's a minus 12 over here. So what do we get there? We get minus 13.6. And then on the 5 volts we get, oh dear, it doesn't look like we've got the 5 volts. We're seeing half a volt, so there must be a problem with the switching in here. Or actually, where is this this I think there's a power plane sandwiched in between the boards. So we've got the ground on the back and the 0 volt. 5 volts is inside the ground plane. So let's have a look here. That diode goes through, charges these 2 capacitors up. This is the output filter. So is it going to be looking? Let's try there. There you go. 5.0 volts. That's close enough. So we've got our 5, we've got our 12, plus 12, minus 12. I need to find out where I can probe the regulated 12 volts. I can't immediately see that. Should have done that before I powered it up. Okay. But I do know that it's on that link that's at the back there, so I think I will probe that very, very carefully. So we'll go back to our 0 volts, and we get 12.3 volts, so that's absolutely fine. Good. Right, so unless there's any other reason why this needs to stay outside of the actual safe case, I don't think there's any soldering I need to do. I might just clean up the bottom of there. Then I think this is good to go back in its case. And then very, very carefully put this back in. Now this cable that's disconnected can go back through there, and they've conveniently left me with that cutout, which is very kind of them. And then we can put this through. That might be asking too much. Oh no, there you go. That goes through as well. So I do watch other people do this on YouTube, and I don't know how they carry on talking whilst they're doing it. I mean, it's just one step too far for me. I can't talk about what I'm doing it at the same time. I was saying, I find it very difficult to carry on talking whilst doing this kind of thing. Like people I see on YouTube, but this video isn't really for people on YouTube. This is for me. So the next thing is I want to hear whether or not it makes any noise. So I want to connect in the speaker, which I think is this one. We won't be able to see anything else, but I guess we'll just be able to notice whether or not anything smokes when we plug that back in. Still getting 5 volts, which is good. What I'm going to do now is just spray some deoxit down here. So I have reassembled this now, and we'll see what happens if we power it up now. I should be able to hear the speaker, and we might also be able to see these power lights over here. I can't remember if the floppy drive seeks or not. Could still blow up at this moment if I've shorted something. So let's give this a go. And the power light is on. Oh, that's the floppy drive. I think we might be in business. Some of these lights are really dull, but I think we might be in business here. Okay, so the next thing I need to do is I need to rig up either some kind of VGA input or find a TV or something. I don't see anything smoking, I don't think. Let's press delete. That resets the... What does it do? Yes. Yeah, that looks good to me. I'm quite excited now. So now, now I need to be able to see what it's doing. Right, I don't have a monitor to plug this into at the moment. However, I do know that there is composite video. So what I've done is I've hooked myself up some phono leads that go into an old telly that I've got. And what we'll see is if I poke this in the right area, that is the Riscos desktop there. I can see the little Acorn logo on the bottom right hand side, and I can see the pointer in the middle of the screen. So this machine is working. Now it does have a 15-way VGA socket on the back here, and I do remember back in the dim and distant past that you could put a VGA on it. I have found an old monitor, an old Acer monitor, old, by this standard anyway, with a VGA input. So now I just need to find a cable. So good news, I managed to find a VGA cable in the attic in a monitor box, which I put up there for no apparent reason. But I mean, the cable is so thin, it can't be more than 50 microns in thickness. So thickness is more than 50 microns. Right, okay, fine. We'll try this, see if it works. Turn it on. If that doesn't work, I'll turn it on, hold down delete, and we'll see where we get. So it's on. And then maybe on the monitor I need to change it's saying DVI. No, you need to be on... No, it's not on that one. How do I change the mode? Wait! It's working! Brilliant! Oh, fantastic! Now, I don't have a mouse, so I can't do anything with a mouse. Keyboard. Right, so F12 should bring up the supervisor. I don't think that's working. I don't think the keyboard's working, so we'll need to have a look at the keyboard. Definitely plugged it in. Yeah, so the caps lock light is on. I can't turn it off. The num lock is off and on, so at least part of the keyboard is working. I'm sure it's F12 that brings up the prompt. Okay, I'll have to have a look at the keyboard, but I need to obviously get a mouse now and see how that goes. But that's the result. That I mean, that's very positive now. I don't know where I stand on if I needed a new keyboard, but that looks like it's working really well. I'm very pleased. Obviously, we've not tested the floppy drive or anything like that, but it's looking good at the moment.